Okay, so here are a couple of good problems about density or intensity and decibels. So this one's counterintuitive. You have one speaker that's playing 100 decibels. It's a really loud speaker. You turn on a second speaker. What do you think the combined decibel level, the sound intensity level, will be? Your gut tells you that it would be 200 decibels, but decibels are not linear. We cannot add decibels together. Okay, so let's work this out. Let's call the intensity the power per square meter, watts per meter squared, of one speaker. We'll call it I sub s. Then we know the decibel level. Remember, this is our formula for decibels. 10 log base 10, this is common log, base 10. The intensity of your source divided by I naught, where I naught is about the threshold of human hearing, 10 to the negative 12 watts per square meter. So we know IS, the intensity from one speaker, satisfies this. Well, what if we make it two speakers? Well, the intensity is linear. The I's are linear. The decibels are not, but the I's are. So two speakers would have twice the power per square meter. And now we just use rules of logs. Remember, log of a product multiplied outside becomes added inside. So log of 2 times IS would be log of IS over I naught plus log of 2. And we could distribute that 10. 10 times this, well, that was the intensity or the decibel level from one speaker. That's 100 plus a 10 log 2. 10 log 2 is about 3. So our new decibel level is about 103 decibels. So one speaker was 100 decibels. Two speakers would be about 103. Remember, the decibel scale is a logarithmic scale. For every 10-fold increase in intensity, if you had 10 speakers, you would go up by only 10 decibels. So one speaker was 100, 10 would be 110 decibels. If I multiply by 10 again, 100 speakers would only be 120. 120 is very, very loud. Remember, the decibel scale is a logarithmic scale. 1,000 speakers would go up by another 10 decibels. So that would be 130 decibels loud. And that's really, really loud. Okay, here's another problem. Okay, pause the video and read the question. Okay, hopefully you've done that. So part A, we want to find the intensity at the source. Okay, so we know that our decibel level is 53 decibels. We know I naught is always 10 to the negative 12th. We want to find the intensity at point A. So we want to find I. So 53 equals this, divide by 10. To solve this logarithmic equation, we convert to exponential form. 10 raised to the 5.3 equals what's inside. So we make both sides powers of 10. So you may have to refresh your college algebra here. We're just solving a logarithmic equation by converting to exponential form. And then here, just multiply over. We get I equals 2 times 10 to the negative 7th watts per square meter. That's the intensity, not the decibel level. That's the power per square meter at the source. Part B says how far do you need to go to get 1/4 the intensity? Well, remember, intensity drops off like 1 over r squared. So, like, we go through a bunch of math here. We really don't have to do that. Okay, so A is 3 meters from the source. I think here I said A was the source. A is 3 meters from the source. We want to go far enough out that we get 1/4 the intensity that we had at A. When intensity drops off like 1 over r squared. So if you want 1/4 the intensity, you would have to go twice as far. If you double your radius, you'll get 1/4 the intensity. Now here's all the math backing that up. The ratio of two intensities. Remember, I is watts per square meter, and we think of I as being an expanding, our power is radiating out in a sphere from our source. So at some distance r away, the surface area of that sphere would be 4 pi r squared. So I is the power divided by 4 pi r squared. So the ratio of two intensities at different radii, I2 over I1, would be R1 squared over R2 squared. We can solve this for R2. We know the intensity at A. We solved that up there just a minute ago. We know R1 equals 3. We could solve for I2 and plug everything back into here and get R equals 6. But again, all of this was pointless. We didn't have to do any of this. If you want to be 1/4 the intensity, you go twice as far. If you wanted to be 1/9, you would go 3 times as far, because intensity drops off like 1 over r squared. Part C says, well, what if you want to get 1/4 the decibel level, the sound intensity level, your book likes to call it? How far would you need to go? Okay, so this one's a little more complicated because we've got logs in here. So I know the decibel level at point A was 53. I want this guy here, the new spot, to be 1/4 of that. So 53 over 4 minus 53, we get this number. We're going to solve this for I2 in terms of I1. We already found I1 up above, so now we know I2. And now we can use our formula, our ratio of two different intensities versus radii, to solve for R2. You should work through all these details on your own, but this is the key. R2 is 292 meters. So to get 1/4 the intensity, we only had to go twice as far. To get 1/4 the decibel level, we had to go many times, almost 100 times as far. So intensity, the I's obey the inverse square law, but decibel level, what your book calls sound intensity level, does not.